All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, I am here again with the 75 days hard challenge of physics, and this is the day 7th of this challenge. Okay, so guys, my name is Dr. Umashankar. I am your physics educator, and likewise, like in every session we do, in this session also we are going to solve some previous year questions of physics so that we move even more closer, to our destination, that is the NEET 2024 examination going to happen on 5th of May 2024. So let's start with the question. So here we go with the first question. Let's try this question. The live student can respond to me. Okay. So let's try this question. I'm very sure we can do it. So here is the first question, guys, of today. Let's try to solve it. I'm very sure we can do it. Please go for it. So, sir, how we can do this question? The live student can start telling me. So, see, it says the position of a particle with respect to time t along x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t is in second. What will be the position of the particle when it achieves the maximum speed along the positive x direction? Okay. Okay, so what we can say, so it reaches the maximum speed. So we need to firstly get the velocity. So dx v is equal to dx by dt. So this is going to be 18t minus 3t square. 18t minus 3t square. Now it says what will be the position of this particle when it achieves maximum speed along the positive x-axis. So something achieving the maximum speed, so for that you have to use the concept of differentiation that I have taught to you. So when we want to find the maximum or minimum of any particular parameter, how we need to do that? How do we need to do that? So sir, we need to differentiate that parameter and put it equal to 0. So what we can do, sir? So we can differentiate it dv by dt. It will become 18 minus 60, 18 minus 60, and this is going to be equal to 0. So from here we can write t is equal to 3 seconds. Okay. Okay, so it says what will be the position of this particle when it achieves the maximum speed. Okay, so what is going to be the position, my dear? So we need to, so first we have understood that it will have the maximum speed when the time is 3 seconds. Now to find this position at t is equal to 3 seconds, we need to put this into the x formula of x. So it is going to be 9t square minus t cube. So from here x will become 9 square minus 3 cube minus 3 cube. So what it is going to become? It is going to become 81 minus 27. So 81 minus 27, it is going to be equal to 54. Isn't it? It is going to become equal to 54. Now let's move to the next question. I'm very sure we can do that also. Okay, so let's try this one. I'm very sure we can do it. Please go for it. Please go for it. I'm very sure we can do it. Let's try this one. So it says displacement of a particle is represented by the following equation. So we have this equation of displacement where s is in meter and t in second. The acceleration of the particle at t is equal to 1 second is. So we need to find acceleration here. So for that we can go with ds by dt first. So v is equal to ds by dt. So ds by dt, that is going to become 9t square plus 14t plus 14t plus 5 plus 14t plus 5, right? Okay, and acceleration is then going to become, so dv by dt. So it will become 18 of t plus 14. 18 of t plus 14, right, beta? 18 of t plus 14. So what we are going to get from here, beta? What we are going to get from here? So it says that the acceleration of the particle at t is equal to 1 second. So we need to put t is equal to 1 in this. Now when we'll be putting the t is equal to 1 here, so it will become 18 plus 14. That is going to become 32. That is going to become 32. I hope it is fine to everyone. Right? Now let's move to the next question. Let's try one more question. Okay. So let us see some more questions. Let's try this one. I'm very sure we can do it. Please go for it, Buddha. Please go for it. So how could we do it? So it says the displacement of a particle varies with time as is equal to at square minus bt cube. The acceleration of the particle will be 0 at time t equal to. So what is going to be the acceleration, beta? So the acceleration is going to be, we know, dv by dt. Okay. Now what is this v? So v is ds by dt. So if I find this ds by dt, it will become 2at minus 3b t square. 280 minus 3b t square. Then what is going to be the acceleration? So we can have it differentiated once more. We can have it differentiated once more. So it will become 2a. It will become 2a minus 6bt. Okay. So I have differentiated this again and it is equal to 0. Okay. So it says the acceleration of the particle will be 0 at time. So we'll put it equal to 0. So very easy. It will become a is equal to 3b of t. So t will be a upon 3b. Right. So this is going to be the answer for it. Okay. Now let's try one more question. Very interesting. See, we need to solve as much as question as possible, you know. Okay. So see, in physics, the right way is to approach is always that we must solve multiple questions. Okay, as many as we can. More you do, better you will feel, and more near you will be your end goal. Let's try this one. Let's try this one. I'm very sure we can do it. So a displacement time graph of a moving particle is shown below. The instantaneous velocity of the particle is negative at. Now what is the instantaneous velocity, beta? What is the instantaneous velocity? So instantaneous velocity is ds by dt, that is slope of this curve. Okay, slope of this curve. Now, if we observe the slope, so what is going to happen? So let's observe. So for C, this is acute angle. What we learned, so we learned when the angle is acute, the velocity is positive. Now for D, if I make the tangent, this is again acute. Now for E, if I draw the tangent, how the tangent is going to become? So the tangent will be going like this somewhat. Okay, this is going to be the tangent, right? Now this is becoming obtuse, right? Clearly this is obtuse. So when the theta, when the angle that the tangent of the curve is making from the positive x-axis becomes obtuse, so in that case the velocity becomes negative. Okay, do we know that? Yes sir, absolutely we know that. So here it will become obtuse, so that means E, at the point E, this will become negative, right? Now let's try this question. The live students, please you can respond to me. Let's try to solve this question. Please do it. Please let's try to do it. Let's try to do it. I'm very sure we can try it. No problem at all. Okay, let's try to do it. So how can we be doing it? So it says the particle moves along a straight line such that its displacement at any time t is given by s is equal to t cube minus 6t square plus 3t plus 4. The velocity when acceleration is 0. So what is acceleration? So acceleration is dv by dt. Acceleration is dv by dt. So now when we have to find the acceleration, that is dv by dt. So for that firstly we will be needing the v. So v is ds by dt beta. So what is going to be ds by dt? So it will become 3t square minus 12 of t minus 12 of t plus 3. Okay, plus 3. So 3t square minus 12 of t plus 3. So that is going to be the v. Now what is going to be the acceleration, my dear? So acceleration is going to become how much? So acceleration is going to become beta. Acceleration is going to become dv by dt. So it will become 6t minus 12. Okay. Now it says the velocity when acceleration is 0. So we put it 0 here. So t will become 2. T will become 2. So what is going to be our velocity? So it will become 3 into 4 minus 12. Okay. Okay. So 3 into 4 minus 12 plus 3. So this is going to become A option, right? So it is coming out to be 3 obviously. Okay, right? Wonderful. Now let's try one more question. Okay, very interesting. The live students, please respond to me on this, how we will be able to do it. Please go for it. Please go for it. Let's try it, my dear. Please go for it. How can we do it? Very simple question. So how can we do it? So which of the following does not represent motion in one dimension? So which one of the following does not represent the motion in one dimension, sir? This one. Okay. How come, sir? How come? Because this is not possible case of, sorry. This is, you see, so in this, sorry. So please observe. Yeah. So which one of the following curve does not represent motion in one dimension? So that is going to be the B option. Because when we are talking the motion in one dimension motion, the body can have at a time one velocity, but not two values of velocity. I hope it is clear to everyone. Yeah. Okay. This is not possible in one dimensional motion. Okay. Okay. Now let's try this question. So see, we have to solve. Hello, Shisai. Yeah. So okay, let's try this one. So I can see in kinematics many questions are asked from the motion and the gravity, but that we haven't completed yet on the channel. So so today I'll be completing the products of the vector na. So afterwards there will be more scope of solving questions. So meanwhile, you can try this one. What is the answer? Let us check. Yeah, wonderful. So it says if a unit vector is represented by this, the value of C. So, sir, what is the unit vector? So, unit vector is something, unit vector is basically something which has a magnitude of 1. So, this is your unit vector. Let's call it A cap. Okay, so A cap is given as zero point 0.5 of I cap plus zero point A of J cap plus C of K cap, right? Now we understand that the magnitude of this, so what is going to be the magnitude? That is zero point 0.5 square plus zero point 8 square plus C square, it is going to be 1. Because magnitude of any unit vector, yeah, is 1, right? So from here we can get C. So C will be becoming 0.11. C will be becoming 0.11. Right? Now we are having to do one more question. Let's try. So some questions we already have done. Hmm. Let's try this one. So this question has been asked multiple times. Yeah. Please try this one. Hmm. So what is the answer, Bida? So, sir, obviously the answer is 90 degrees, sir. We have seen this in the sessions also. No? So it says two vectors, the sum of two vectors, okay, the magnitude of sum of two vectors is equal to the magnitude of difference of two vectors. Difference of two vectors. This is going to be when possible. So this is possible only when cos is theta is 90 degree. Okay, we remember that na? A is square. So what is uh, the magnitude of it? 2ab cos theta, right? So we can put root, but root will be cancelled out. Let's put the root here. And a minus b was a square. So we developed the formula for this also. Minus 2ab cos theta. So from here, root, so it will become cos theta will become 0. That means it is 90 degrees. Okay, this is something we have seen already. Okay, yes or no? Yes, sir. Okay, let's try this one. Let's try this one. A lot of questions are here in the product. Okay, let's see that. Please think again. It seems not right. Please go for it. It seems incorrect, my dear. Please think again. It's not that difficult. Please think of something. According to you, these must be the answer. How you approach this question? How have you approached this question? Yeah, I thought you would be giving the answer to this question like very easily. How you approach this question? I want to know. How have you approached? What concept you have applied? Graphically you did? Acha. Let's see. So it says the magnitude of vector A, B, and C are 3, 4, and 5 units. If A plus B vector, A vector plus B vector is equal to C vector. So what is A plus B? It means resultant of A and B. It means resultant of A and B, right? So resultant of A and B is what? Sir, it is root over A square plus B square plus 2AB cos theta. Do you agree to it or not? Please answer me. Yes or no? What do you think? Is it right or wrong? Hmm? Right? Okay? Please understand this. Do you agree to it that the magnitude of this is this? And this is equal to the C vector. Okay? This is equal to if A vector plus B vector is equal to C vector. So can we write it like this? So A vector plus B vector is equal to C vector. So what is the magnitude of this C vector? This is 5. Okay? Right? Now A vector plus B vector is equal to C vector. That means the magnitude of this A plus B vector is also equal to the magnitude of C vector. Two vectors are only equal when their magnitude and direction are the same. Yes or no? Do you agree to this or not? Hmm? Can I write it equal to 5? Hmm? You agree to it. Huh? No issues at all. Now if I square these both sides, so it will become a square plus b square plus 2ab cos theta, and this will become 5 square. है ना? So a square plus b square, that means 3 square plus 4 square. I'm just putting the magnitude because you know in this a, b are the magnitude. So this is going to be 3 into 4 cos theta is equal to 5 square. So can we write, so 2 and 12, 24 cos theta is equal to 0, isn't it? So theta is equal to 90 degree. That means 5 by 2. Hmm? Isn't it? Please answer me. Now you have used the graphical method. Okay, chalo, let's do that. So the magnitudes of A, B, and C. So if this is your A vector, if this is your A vector, This is your B vector. Let's suppose I don't know. Now this is going to be the resultant of it. This is going to be the resultant of it. That is the C vector, isn't it? Two vectors are given by two sides of the triangle taken in the same order, right? So A and B are those, okay? Then the resultant is given by the third side in the opposite order. This is how you have to do it. Now please think, if this is A is given to be 3, if this is 3, this is 4 and this is 5. So this is only possible, as you said, that it is a Pythagoras triplet. So if this is 3, this is 4, this is 5, it is only possible when this angle is 90. So clearly the angle between vector A and B is 90. So you do it by any approach, you are going to get the same thing. Isn't it? Yes or no? Please answer me. What do you say? What is the mistake that you have made here? Sisai, can you respond to me on that? Hmm? I think you got this angle. You have given the answer to this angle. Na? You thought, this is not asked. Na? This is the angle between A and C. If they would have asked in this question that what is the angle between A and C, then this would be your answer, isn't it? This is not your answer. You have, I understood what you have done, but I hope that you have understood that what has to be done, isn't it? Okay, let's try one more question. Uh, yeah, very simple question. Yeah. Please go for it. See, in vectors, you have to be, very, very careful that which angle is asked, what is the approach you are using. Yeah, you found the angle between A and C, right? Very good. So it says a motorcycle moving with a speed of 15 meter per second is subjected to an acceleration of 0.2 meter per second square in the direction of motion. Calculate the speed of motorcycle after 10 seconds. Okay. So V is equal to U plus ATV in this time. Okay. So initial velocity is 15. Acceleration constant it is given, that is zero point 0.2 and it is 10. Okay. Okay. So V is equal to what happened? A motorcycle moving with speed of 15 meter per second is subjected to an acceleration in the direction of motion. In the direction of motion. Oh, it is point. Oh, right. It is right only. Okay. So it was going to be 17 meter per second. Yeah, it was very easy. Now let's try one more question here. Let's see if we can think it that way that it has to be thought about. Okay. Let's try this one. Let's see this. Please do it. So how we can do it? So the x and y coordinate of the particle at any time are x is equal to x is given, y is given. Okay, x is given and y is given, where x and y are in meters and t in second acceleration of the particle. So can I write it like this? See, so basically so here this is two dimension. So we can use the concept of Cartesian simply. So can I write it as this xi plus yj? Okay, so something is displacing in both x and y direction. So I can represent the vector in the Cartesian as xi cap plus y j cap, right? Can we do that? Yes, sir, absolutely. Now, if I want to find the velocity, so velocity is vx I cap plus vy j cap. Okay, okay. So to find the velocity, so if we differentiate the x, what we are getting? We are getting 5 minus 40. Okay, so this is going to be your I cap, and what is going to be the y cap? It is going to 10 j cap, right? Okay, just I have differentiated x with respect to t and y with respect to t, because we obviously know vx is equal to dx by dt and vy is equal to dy by dt, right? Good to go. Now, what is going to be the acceleration? So acceleration is the derivative of the velocity. So if I differentiate this, I will be getting minus 4 of I, and this is constant, so this will become 0. So what is acceleration? It is minus 4 I cap. That means it is minus 4 in it is 4 in minus I direction. So we can write it as minus 4 given the options. Clear? Please answer me. Is that clear to you or not? Please answer me. Okay, moving to the next question. Let's try this one. Please go for it, beta. Very simple question, isn't it? Hmm? So a particle is starting from the origin moves in xy plane. The it coordinates at a later time r. So if I say xy, so its coordinate are going to become root 3 and 3. Its coordinate are root 3 and 3. Okay, root 3 and 3. So now this is the position vector to it. Let's call it r bar. So the path of the particle makes angle. So this is the angle. This is the angle. So this is going to become, so this is 3, this is root 3. So this is going to become tan theta is equal to 3 by root 3. That means root 3. Now we know that tan 60 is root 3. So this is going to become the answer. Isn't it? Please answer me. Please answer me. Right? Okay. Wonderful. Well, let's see if we can do. So how many questions we have done till now? Check that. Okay, so before that, we can try one more question. Last question. Hmm. So this is how the questions of kinematics are getting us. I'm just taking the PYQs. Okay, let's try this one. This is also simple only. The whole physics is simple only. Beta. Okay, let's try this one. I'm quite sure we can do it. Please go for it. Take some time. No issues. No worries at all. Please take some time. Any answer? Please take time. No issues. Any answers, beta? You can't do it. See, you need to find the velocity. Okay. Now see, sometimes what we have to do, we have to think a little bit additional. Okay. So see, this question is very very simple. How it is very very simple. So now, if I have given you, let's forget this question. If I give you that a is equal to, let's suppose, 2t, and I ask you that what is the velocity at t is equal to, let's suppose, 3 seconds. Will you be able to do that? Please answer me. You get my point, what I'm trying to say. If I ask you that the a is equal to 2 times t, I give you a function of a is equal to, Shitani, just forget about it. So a is equal to 2t, and if I ask you what is the velocity at 3 seconds, okay, at 3 seconds, okay, 0. So that's at time is equal to 0 to 3 seconds, 0 to 3 seconds. So now what is going to be the acceleration? So you can say, so yes, so very simply we can do. We can integrate the acceleration and then we can put the limit from 0 to 3 and we'll easily get our answer. Isn't it? Isn't it, my dear? Yes, sir, most certainly. Right. Now, in this question, how this question is different from what I have asked. So in this question, you don't have any acceleration. You don't have any function of acceleration. But if any way from anyhow, yeah, if anyhow you get the acceleration from here, you will be going to get the velocity. So now this question is given, it is given that force is 6t I cap plus 4t j cap, 4t j cap. Now, if this is the force, so in general, what is force? So force is mass into acceleration. So acceleration is going to be force upon mass, right? Now, if we divide this with the mass, so we will be getting 6, that will become 3t of I cap plus 4t. So this is acceleration. This is the acceleration vector you are going to get. So you divide this whole equation by mass 3. So this is going to be 2t of I cap, okay, plus 4 by 3t of j cap. Yeah, do you agree to it? Did you did this till this point? Have you done till this point? Yes or no? Okay, now once this has been done, so you can get the velocity vector. So you need to integrate this 2t between 0 to 3. So what it will become? So now let's integrate it separately. So now you understand that you have ax, that is 2 of t. Yes or no? You have ay, that is 4 by 3 of t. 4 by 3 of t. Now if we have this ax, if we have this ay, so can I have this vx? Absolutely, sir. It will become 2 uh, t square. It is going to become, so 2. So how we are going to, so this is 2 integration 0 to 3, and this is dt, 0 to 3 and dt, right? Okay, so this is going to become 9. Okay, I think you have done the, so I think something missing there. I think something is wrongly mentioned here. Just let me check the, because I think you have given, hmm, so we have this acceleration. Okay, So see, I think you have given the right answer only. So this is going to be 2t square by 2. So t is going to be t square, 2 to cancel out, so t square will become 3. Okay, so Vx is going to be 9. And what is going to be Vy then? It is going to be 4 by 3 t square, assuming that the body is at rest at time t is equal to 0. Okay, so let's not take it like limit. Okay, just 1 minute. Huh? Okay, so now when I integrate this function, I'll be getting t square plus c, right? Now, when assuming that the body is at rest when t is equal to 0, so if I put t is equal to 0 and so c is also is equal to 0, so though both way we are getting 9 only. So Vx is equal to 9, no problem. And then Vy, it is going to be Vy, it is going to be 4 by 3 t square by 2. So this will become 2 by 3 of t square. And again you put this 9. So this will become 6. So the answer must be 9i plus 6j. Right? Okay. Hmm. So ax, what you are saying, then we get 60 plus 40. Hmm. I didn't get what you are saying. Okay. V is equal to u plus 80 if we apply. Oh, yes, yes, yes. So in this case, oh, yes, 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 yes. At this point, I was missing here. Okay. So V is equal to u plus 80 if we apply. So initial velocity at time t is equal to 0. So this is u. And what is the acceleration? Acceleration is so 3 kg in the direction of assuming that the body is at rest. Okay, so this is the case of sorry, just let me correct this question. Okay, so V is equal to, so this is actually we cannot do actually this way. So V is equal to, so first of all we have to get this acceleration. Okay, so now V is equal to u plus 80. So what is the acceleration? Acceleration in the x direction is 2t. So see, this will be your acceleration in x direction. It will be 2t square, right? Okay, just one thing I missed here. That is, so sometimes see, this was a good question. So assuming that the body is at rest at time t is equal to 0. So that is the initial velocity is 0 and the final velocity at the velocity of body at oh. Yeah, that is why we have to read the question firstly carefully. Na? It says the velocity of the body at t is equal to 3 seconds. So they are asking you the final velocity. Okay, the final velocity. Okay, okay. So the final velocity is going to be Vx is equal to 2t square, and similarly Vy, it is going to be how much? It is going to be 4 by 3. Okay, so Vy, so the body is at rest at time t is equal to 0. So it will be 0 plus a of t. Okay, okay. So Vy it is going to be a is what here? A is 4 by 3 of t square, right? So see here we don't have to differentiate actually because here we don't have to do like this. Okay, why sir we are not doing like this? Because here it is at the velocity of the body at t is equal to 3 seconds. So they are asking you the final velocity. Yeah, there will be some difference, na? Now see how it is going to happen. So first of all, see, let's read the question carefully. A body of 3 kg moves in XY plane under the action of force given by this. So force is given. Assuming that body is at rest at time t is equal to 0. So this is initial velocity and the velocity of the body at 3 t is equal to 3 seconds. Okay. It is not asked between 0 to 3. No, no, no. You have not. I am sorry because I haven't read the question carefully. I see to a 2.0 to 3. Sometimes hurrying the things is also disastrous. Okay, assuming that the body is at rest at time t is equal to 0 and the velocity of body at time t is equal to 3 seconds. So they are asking you the final velocity. They are not asking you the velocity between 0 to 3 seconds. So if we are integrating, that means we are finding the velocity between 0 to 3 seconds. Are you getting my point? Hmm. In any given direction, the acceleration is constant only, na? Right? You are saying that it moves with the velocity, it changes with time, right? So see, when they are asking you the final velocity, you are putting this equation, right? V is equal to u plus at. That is like u plus at cannot be applied that way. Okay, but in this case, ultimately we have to find a function now. So there is no other way also. First of all, see, they are asking you between the initial time at 0 and the velocity of body at 3 seconds. So they are asking you the final velocity. Okay, so when they are asking you the final velocity, there is no other way at 3 seconds. Okay, so you have to assume the acceleration to be constant here. So see, here Vx will become how much? So 2t, that is 3 square, and this is Vy, that is 4 by 3, that is 3 square. Okay, that is 3 square. So something is again, like something is going not in the right way. So again, see, this is going to be taken a wrong turn. So see, Vx we have, and we have this. Hmm, see, something, I think something is wrong in this question. Okay. So I think we can get back to this question. है ना? Because you have a valid point. Right? Okay. So let me get back to this question. Something is wrong in this question. Something is missing because see, yeah, because I have taken it from the internet, so we cannot read. Okay, so what is going wrong here? If I can see it, so basically, okay, hmm. So one thing, very good afternoon. So let me check this question. Sometimes question also we cannot trust when we are taking it. So I haven't done this before. Okay, so let's get back to this question again. Okay, that will be the good thing to do. Okay, sounds good. Otherwise, we'll end up wasting more time. Very good afternoon, Bima. So we have like in 5 minutes another session. So in that session, we are going to come up with the vector. Okay. Okay. So let's see each other in the next session. Right. Okay. So guys, in today's session, except this question, so sometimes this kind of question also comes. So we have solved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 questions we have done. Right, 12 questions we have done in today's session. So I hope you have enjoyed the session. So let's see each other after in the next session, in which we will be going to discuss about the vectors. Okay, so that session will be started from 3:25. Okay, yeah, sure. Thank you very much. Have a good day.